So our next method of factoring here in Chapter 6 will be a process called grouping. We specifically only use this process whenever we have a 4-term polynomial, okay? And it's not something that works on every 4-term polynomial in general, but in this class we will actually only be seeing 4-term polynomials for where grouping does actually do something. So the process of grouping, it's mentioned up here, but I'm going to just walk us through in this first example. So we have 4 terms. Now remember, from last section, before we do anything, no matter what the problem actually looks like, if we're factoring, we're going to always ask that question, what's the first step? And the answer is GCF, always. Now, for 4-term polynomials, you gotta have something in common with all 4 terms. So 8, 12, 10, and 15 have nothing that goes into all of them. We've got y cubed, y squared, and y, but this last term is just a constant, so there's no y's in common, so we see a GCF of 1. And that'll happen a lot, but we're gonna always ask that GCF first because there's plenty of times where there will be something, and there's even problems where if you don't ask that GCF first, you can't even do any more or anything with the problem. So it's very important that we remember that first step, GCF. So now, that's out of the way, we can go with grouping on our 4 terms. So the first step mentions grouping them into 2 groups of 2. Now, there's one aspect to this that's very important. Also, I'll point out, when you do a GCF of 1, you do not put it out front. You don't need to do that at all. But when you're doing the 2 groups of 2, it's very important that you put your first 2 together, throw a plus sign in between those 2, and your second 2. That plus is there for multiple kind of organizational reasons. So don't miss that aspect to it. Just first 2 terms, second 2 terms. Now, after you've done this, this problem really just comes down to a question of, do you know your GCFs? Because we're going to take the GCF again, but from each group of 2 instead. There, in this case, was no GCF for all 4, but looking at only 2 terms, 8y cubed and 12y squared, they have a GCF of 4y squared. 4 goes into both of those, and 3y's and 2y's, so there's 2y's in common. So just those first 2 have a GCF of 4y squared. Then think about what's left over. 4y squared times what is 8y cubed? Well, it'd be a 2 and that third y. 4y squared times what is a negative 12y? Well, 4 times a negative 3, and we already have the y squared there. So that would be what it looks like when factoring out that GCF of those first 2 terms. Now we do the same thing for the next 2. Now the GCF of these 2 terms is actually just a 5. 5 goes into both 10 and 15, and there's no y's in common. Don't lose that there was a plus sign there, so it's plus, and then you factor out the 5, and then figure out what's left. Well, 5 times what is 10y? 2y. 5 times what is negative 15? Negative 3. So now we've done the GCF of 2 separate groups of 2. We get to here, and this is where that last question about GCF back in section 6A2 comes into play. Because at this point, and what the step 3 up here mentions, do you see a big GCF? Remember, we had to say that we think of that as 1 term, and that is 1 term, but then we see that whole parentheses expression as something I'm going to refer to as the big GCF. They both have the big GCF of 2y minus 3. And if we factor that out, right, if they factor that term and a factor of that term, and we ask the question what's left, it's the 4y squared sitting out of that one in front of that 2y minus 3, and the plus 5 sitting out front of that one. And in doing that, basically a third GCF, we now have a factored form. It is something times something, and that's our goal. So notice, grouping is really nothing more than, once you get this thing split into 2, GCF, GCF, big GCF. And again, like I said, the big GCF doesn't have to occur in general, but in our class, in these examples we see, this will work. We're going to give you problems where grouping does work, which means these things will match. If they don't match, basically in this class we're saying you made a mistake because they need to match so that we can factor it out as a single GCF. So let's look at a couple more. All right, so we need to factor. So our first step is GCF. 4 terms, 15, 25, 6, and 10, nothing in common. And variable-wise, there's nothing in all of them, so GCF is a 1. So now, groups of 2. 15ax minus 25x would be my first two. Remember, always plus. So that means, for this particular problem, that was a minus sign, so just keep it attached to that third term for the moment, like so. Keep it a negative 6ay. Now, these two terms, GCF, I see a 5 would go into both, and I see each has an x. So, what's left over? 5x times 3a, and 5x times a minus 5. Looks good. Now, over here, we're going to remember that trick or that idea that if the first term's negative, we don't like it, and we'll factor out a negative with a GCF. Well, what that means is, factoring out a negative sign, this was a plus, but now we will change it to a minus. That's like that negative sign coming out. And then we've got a 2 in common and a y in common. So negative 2y being factored out, but now keep in mind, that's the GCF you're distributing through to ask what's left over. Negative 2y times what is negative 6ay. Negative 2 times a positive 3 would give me negative 6. And we have the y, but we need the a. Negative 2y times a negative 5 would be all I need to get back to the negative 10y. And again, remember, anytime you factor out a negative sign, really, you just remember your signs are all going to change. That's the effect that has. And then you can move on to the GCF itself. Most importantly, though, in this form, we again see we have our big GCF. This time it's 3a minus 5. So 3a minus 5 in common. And then we ask for those leftovers. Well, in front of it there is 5x. In front of it there is minus 2y. And there's our factored answer. All right, and one more. 4 terms, but first step. Did you say GCF? I hope you did. GCF, nothing in common in the numbers, and that's a constant, so no x's in common, so GCF of 1 again. Like I said, that's going to happen plenty. So now we're into grouping, which puts those two together, always plus those two together. GCF of these first two. 2 goes into both, and there's 2 x's, right? X squared in common between both those terms. Asking what's left, 2 times a 3, and I need one more x. Here, 2 times a negative 4, and I've got all the x squareds already. So that would be the remainder when you're factoring out 2x squared. Now, looking at 3x minus 4, we realize there's nothing there in common. Here's the one place I think it's a good idea. If the GCF of things is 1, go ahead and put a 1 out front there to show yourself, first of all, that you tried to factor it and there was nothing in common. But also, very importantly, it lets us maybe more easily see this next step. We first of all see the big GCF. Those have to match 3x minus 4. So that factors out. And then the leftovers, we see that 2x squared there. And by putting that plus 1 there, it's just easier to make sure you see that that plus 1 has to be a part of the leftovers, right? We cannot leave that plus 1 off. If we didn't have that there, that would definitely not be something that multiplied back here to give us these 4 terms. That plus 1 makes all the difference there.